Welcome to True Projects. In this video, we are going to explain about the project which is Marine Animals Detection using Yolo. So before getting into the project's execution, let us understand what is the project about. So what are these marine animals? We all know that marine animals are the living beings that are living organisms that live under the salt water bodies which are nothing but oceans and seas. So detecting these marine animals comes under the concept called marine technology. This marine technology helps us in understanding what are the resources available in the oceans. So after understanding what are the resources available in the ocean, we can utilize them. So this marine technology, it helps us in understanding and we can use vast resources of the oceans using this technology. Moving on, due to the increase in the human activity in marine environments, there is need for underwater object detection. And this underwater object detection comes under the concept called marine technology. Here, the objects refers to marine animals. So in this project, we will be developing a system that will be efficiently detecting marine animals. So why we have to detect these marine animals? Because if there are any submarines that go through oceans, it is important to navigate safely. So if they detect marine animals, they can navigate safely. And it is important for resource exploration, environmental monitoring, and conserving delicate marine ecosystem. Traditionally, Har cascade, sift, and surf, these were the techniques and various detection algorithms that are faster RCNN, SSD, and mask RCNN. These were existing techniques that were used for detecting marine animals. These had their individual strengths as well as limitations. So these limitations were they face the problem of computational complexity, and they had the difficulty in detecting small and distant animals, and they could not detect properly in the real time, and they had low accuracy. So to overcome these limitations, in this project, we are proposing the algorithm called Yolo, which is you only look once. It is an real-time object detection algorithm. So we are using it for detecting marine animals using an underwater imagery dataset. So that dataset encompasses various marine species, different environments, and in that imageries, we will have different underwater scenes. It encompasses of different lightning conditions, different water turbidity levels, and marine habitats. And we use mean average precession recall to evaluate this YOLO algorithm, that is how it is performing well. By doing so, it will detect accurately marine animals. Moving on, to implement this project, we need software and hardware requirements. We need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need Windows operating system, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In the project, we built all these algorithms. So these are the proposed algorithms. We built different versions of YOLO because to compare and select the best version which performs well. Along with the proposed model, we also built RetinaNet, SSD, and faster RCNN to show the comparison between proposed and existing. So let us know what is YOLO. YOLO, it stands for You Only Look Once. It is a real-time object detection algorithm, and it processes images or the video frames in just a single pass to detect and localize the objects. It divides the input image into a grid and predicts bounding boxes and class probabilities for objects within each grid cell, enabling fast and efficient detection of multiple objects in real time. YOLO, it detects marine animals by analyzing images in real time, and it divides the images into each grid cell and predicts bounding boxes and class probabilities for each grid cell. Specifying for detecting marine animals, the YOLO algorithm is trained on a dataset that contains labeled images of various marine species. During training, it learns features and patterns that are specific to marine animals such as body shapes, colors, and textures. When it is deployed for detection, YOLO examines the entire image at once, enabling it to efficiently detect marine animals in different positions and orientations within the frame. By analyzing features learned during training, YOLO accurately identifies marine animals and assigns bounding boxes around them, along with the corresponding class probabilities indicating the likelihood of each detected object being a marine animal. Although YOLO versions have similar objectives, they differ from their architectures. YOLO V5X6, it has Focus SP3 and CSP Darknet 53 as a backbone. And Yolo V3 uses Darknet 53 as a backbone network, and Yolo V8, it introduces several architecture refinements, including a revamped backbone network, that is path aggregation net, for better feature fusion and focus laws for addressing class imbalance issues. From all the versions, Yolo V5X6 has performed well, so we are using that for deploying it in the front end. So now we will execute the project. To execute it, first we have to open the code folder. So I'm opening the code folder. Here in the code folder, we have source code files which are required for the project. Now let us understand each file, why is it used in the project. Here in this folder, we have the data set. We have two subfolders in it. One is train and the other one is test. In the train, we have two subfolders. One is images and the other one is labels. In images, we have images related to different marine animals. We train all of these images on the YOLO algorithm to detect marine animals. Now get back. In the labels folder, we have files containing annotations or labels for objects in corresponding images. So each file corresponds to an image file in the images folder. So this particular file corresponds to this particular image. And it provides details about the object locations and classes within the image. Now we'll open the labels folder again. Here, these label files often follow the YOLO format, where each line represents an detected object. So I'll show you a sample. I'm going to open this file. So here, each line represents object class index followed by its bounding box coordinates. In the bounding box coordinates, we have x limit, y limit, height, and the width. This label file, which corresponds to image file, has 5 marine animals. So here we have 5 object classes, which are 5 object class index along with their bounding box coordinates. As we have two different classes here, which are 2 and 3, they represent two different marine animals in the images. So now close this, get back to the data folder. So here we will be opening now test folder. Similar to train folder, here also we have images folder and the labels folder. So we use this folder to test the algorithm that is trained on the trained data. Here, we use this particular folder to train the algorithm and this particular folder to test the algorithm. And get back. Here in the sample folder, we have the images and we'll use all these images to test them in the front end. So these are the test cases for us. Get back. This is the static folder. This folder contains files related to project styling and interactivity. They are CSS, JavaScript, and Bootstrap files. These files are crucial for enhancing visual appeal and functionality of the project's web interface. Moving on, the next folder is templates folder. In this folder, we will have all the HTML pages used in the project. We will have index.html, about.html, etc. And each HTML file represents a different page of the website, and it provides a structure and layout for displaying content to the users. This is the app.py file. This .py file contains front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content that to be presented in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. Now we will execute the project. So to execute, first we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the CD followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. So here we can see current directory is changed to the code folder's path. Now we need to compile app.py file. For that, we need to give the command called python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flash framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and now click on enter. So this is the web page of the project and this is displayed in the browser. This is developed using Flask framework. So to execute, we need to sign up if you are new users. So click on sign up and enter all the registration details. If you are registering newly, I have already registered and I have an account in it. So I will directly sign in. So click on sign in and we need to provide our credentials to login. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a choose file button. We need to click on that for uploading the marine animals images. So click on choose file. These are the test cases that will be used for detecting marine animals. So I'm going to upload the second image and now click on open. Here we can see that image has been loaded and now uploaded. Here we can observe that application has detected one object, that is one particular marine animal, and it has drawn a red color bounding box around it and named it as beluga whale with a 0.92 probability score. Probability score is nothing but it is a confidence level, that is how accurate the model is. So here blue whale is 92% accurate. Now we'll upload some more images, get back, click on choose file. This time we'll be uploading this image. Now click on open. Image has been loaded and now uploaded. Here we can see that there are 4 objects, that are 4 marine animals detected from the image. Seahorse has been detected and it has classified it as seahorse, and a yellow color bounding box is drawn around it with a 0.92 probability score, and a blue tang is detected with a 0.58 probability score. Here yellow tang is detected with 0.5 probability score and it is a yellow green color bounding box drawn around it, and the other blue tang is detected. Here it has been drawn a bounding box, that is pink color bounding box. Now we'll upload some more, get back, click on choose file. This time we'll be uploading this image and now click on open and now click on upload. Here we can see that a orange clown is detected and an orange bounding box is drawn around the marine animal with a 0.79 probability score. There are 2 orange clowns detected in the image. We'll upload some more, get back, click on choose file. This time we'll be uploading this image. Now click on open. Image has been loaded and now uploaded. These images which we upload will undergo pre-processing. Here we can observe 2 objects are detected, that are 2 marine animals, that are seahorse and beluga whale. Here we can observe a yellow color bounding box is drawn around the seahorse with a 0.95 probability score. And here we can see blue whale is detected and a red color bounding box is drawn around it with 0.92 probability score. Now get back. We'll upload some more. This time we'll be uploading this image. Here we can see there are 3 objects detected, that are 3 marine animals, yellow tang, 3 striped dome shellfish, and orange clown, and with their probability scores. We'll upload some more. Now we will be uploading this one. Click on open and now click on upload. Here we can see that one object is detected, that is Barracuda with M003 and with the probability score of 0.83. And a green color bounding box is drawn around it. It is Barracuda Mo. Now get back. Click on choose file. This time we'll be uploading this image. Click on open and now upload it. So here we can see that one object is detected, that is beluga whale with a 0.97 probability score and with the red color bounding box drawn around the whale. We'll upload some more, get back, click on choose file. And now we will upload this image. Click on open and now click on upload. Here we can observe two objects are detected that are two marine animals. One is piranha and the other one is also piranha with the 0.50 probability scores. Get back, click on choose file, and now we will upload this image. Click on open, upload it. Here we can observe there are multiple objects detected. Most of them are orange clown and one is three-striped dome shellfish. Get back. As we have uploaded from the test cases, now we'll upload from the Google. So open a new tab. Now we will search for the piranha fish. So I'm going to save this image. I'm going to save it in the Google folder. So now we will upload it. Click on choose file. So as we have saved this image, click on open. Image has been loaded and now uploaded. Here we can observe that application has correctly classified and detected piranha fish and drawn a orange color bounding box around it with a 0.68 probability score. Now we will search for some more fishes. So get back to the Google. Here we'll be searching for seahorse. So I'll save this image. We'll save some more now itself. So I'm searching for orange clown. I'm saving it. Now we will search for barracuda mo. So save it. Now we will search for blue tang. So here I'm saving this image. Click on save image. And now we will search for three-striped dome shellfish. Fish that is three-stripped. So I'm saving it. So now we will test them. Get back to the application. Click on choose file. So now we'll try uploading the seahorse image. Click on open. Image has been loaded and now uploaded. Application has correctly detected seahorse and it has drawn yellow color bounding box around it with 0.87 probability score. That is, the model is correct for predicting seahorse with a 0.87 probability score. Get back, click on choose file. We'll be uploading this image. Click on open and now click on upload. It has not detected. Now we'll try uploading some more images. Click on choose file. This time we'll be uploading this image. Click on open. Here image has been loaded and now uploaded. It has also not detected the clownfish. Get back, click on choose file. This time we'll be uploading this fish and now click on open and now upload it. Here we can see that the application has correctly identified Barracuda M003 and it has drawn a green color bounding box around it. Get back. As clownfish and blue tang, they were not classified. We'll search for some more images of them. I'm going to save this image. So now we'll get back to the application. Click on choose file. As we have downloaded this image, we will upload it. Now click on open and upload it. Here we can observe the application has correctly detected orange clown and it has drawn orange color bounding box around it, named it as orange clown, and given a 0.69 probability score for that. Now get back. Now I'll show you graphs of the project. Click on about. Here, this is precision and recall graph of Yolo V5X6 algorithm. Here, x-axis represents recall score and y-axis represents precision. Here, blue color represents beluga whale and the orange color blue tang. Similarly, we have all other marine animals. This is F1 score of Yolo V5M algorithm. Here, x-axis represents confidence level and y-axis is F1 score. This is the confusion matrix of the project. And this is the recall comparison graph where x-axis represents recall score of each algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It measures model's ability to capture all relevant instances of a class. It is calculated as the ratio of true positive predictions to the sum of true positives and false negatives. This is precision score comparison graph. Here, in this graph, x-axis represents precision score of each algorithm and y-axis represents algorithm names. Precision is a metric that measures the accuracy of positive predictions made by the model. It is calculated as the ratio of true positive predictions to the sum of true positives and false negatives. Now click on sign out. In this way, just by uploading marine animal images to the system, it will detect which marine animal it is.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.